also recording this session. So if you want, you'll be able to, before I get all of them on my, yeah, okay, I can read that easily. Let me put some of the others on there. Is there any page that's more important than the others? Because I doubt we're going to have time for 5 pages worth. Just it's not, typically when people send me 3 pages, it's tough to cover even 3 pages in one session.
Yeah, these ones are pretty quick by the looks of it.
All right, let's have a look at it. Do we want to start with 1?
I already figured out 1.
Okay. About 2.
Yeah. Is 2 a hemisphere?
I can only presume it is, since they don't say. If it was not a hemisphere, we would have no way of doing it. So the fact that they don't define it, but they give you the formulas for everything, yeah, let's call it a hemisphere. So what would the volume of that entire hemisphere be? Or, yeah, of the entire half sphere. Hold on a second. Let me get to where I can write on this thing. So the volume of a hemisphere is 2/3 pi r cubed. Fill it in.
Yep.
So if we were considering an entire hemisphere without this chunk taken out, what would it be? What's the rate? What's the radius?
Would it just be 2/3 pi r?
What's the radius going to be? They're giving it to us in the picture.
24.
Okay. So 24 cubed. That's what it would be if it was an entire hemisphere without a chunk missing. Well, what percentage of an entire hemisphere do we have?
We have about
Exactly.
20%. No.
If it shows an 80-degree chunk missing.
25%.
Well, if that was 90 degrees, we would be missing exactly 25%. Because what we do is we put that angle divided by 360. That's what we're missing. Well, in this case, it's 80 divided by 360. Okay? Which means the amount of the hemisphere we still have is 280 divided by 360. You see that?
Yeah.
So we're going to take this volume that we got from the entire hemisphere and multiply it by this fraction, because that's the fraction of the hemisphere that we have. 28 over 36. So there's your answer once you convert that to a number. You have your calculator?
Let me grab that real quick.
Okay. Again, this isn't the important part. The important part is setting up the formula, which we've done already.
And that would be 938.28.
Doesn't sound right. We got to take 24 cubed.
All right.
And leave your answer in pi. In other words, the only thing you want to do on your calculator is 24 cubed multiply it by 2/3, multiply it by 28 divided by 36, and then we'll just put a pi after that and give our answer that way.
Okay.
I presume that she wants the answers in terms of pi. Or does she? I don't know. On this first one, it looks like she had you rounded it to a decimal.
Yeah.
Do you know which way she wants it?
Either, I think, works. 7,168.
That makes more sense. And then I would just put pi after that.
All right.
Okay. All right, let's look at number 3. Yeah, at this point in your math career, you want to be as precise as possible, and pi is more precise than anything you can write other than pi. Doesn't matter if you carry it out to 15 decimal places, it's not going to be as accurate as pi. All right, how do we figure the volume of this prism? All prisms are pretty much the same. What do you do to figure out their volume? You take a prism is defined by the fact, well, you have two equal bases that are opposite one another. In other words, can you see my mouse here?
Mm-hmm.
Okay, see this base, this triangle? That's the same as the triangle in back, exactly. And it's uniform between those two bases. So we're going to take the area of this triangle and multiply it by its thickness, 11 millimeters. Okay, so first of all, we have to figure out the area of one face. Well, they're only giving us these two dimensions. So we need to figure out that dimension because that's going to be our height.
So 25 squared minus 24 squared, and take the square root of that.
Yeah, very good. I think that that is a special Pythagorean triangle. I think this might be, I'm wanting to say 8, but maybe not. I don't know. You got the calculator. What do you get?
7.
Okay. So what's the area of just the triangle?
Does that work?
I didn't check it. I'm assuming your calculator is correct.
Yeah.
But that sounds right. I think this is one of those Pythagorean triangles, a 7, 24, 25 one. So what's the area of this face? It's the general for area of a triangle?
Base times height?
1/2 base times height.
Okay, so 24 times 7 divided by 1/2.
Divided by 2. Or multiplied by 1/2. Not quite the same. When you say divide by 1/2, that's the same as multiplying by 2. But in this case, we're going to take that total and divide by 2. We're not going to divide by 1/2.
All right.
We're multiplying by 1/2.
Yeah. That's 84.
Okay. So the area of this face is 84, and the volume of a prism is the area of one of the bases times its width or thickness or whatever you want to call it. In this case, the measurement that's 11 millimeters. So the volume is going to be 84 times 11.
That's 924.
And what are the units on that? What did you say? I didn't hear. I still didn't hear. Cubic millimeters, is that what you said? Wonder if there's a problem with our sound. All of a sudden you're cracking up a little bit. Say something again. Let me make sure our sound, because I have another way we can do the audio if this isn't working.
All right. Can you hear me?
Yeah, I can hear you fine. Okay. All right, let's look at this trapezoidal pyramid. Do you have a formula for the volume of a trapezoid? Let's see, they gave it to us. Let's look at it. A pyramid, cone. In other words, this formula works for a pyramid or a cone, which is the area of the base times its vertical height divided by 3. So the volume of this thing is the base of the area, the area of the base, excuse me, times the height, which is 36 divided by 3. So let's talk about the area of the base. What kind of base do we have?
What do you mean?
What's the base of this figure look like? They're showing it to you with the dotted lines.
So,
It's
trapezoid?
It's a trapezoid, exactly. In other words, when I first looked at it, I thought it was hexagonal. In other words, I thought we had a hexagonal pyramid. But we really don't. We have a trapezoid for the base. A trapezoid that looks like this. Can you see that in this area here?
Yeah.
Where this is 15, this is 22, and the height is 8. So what's the area of a trapezoid formula?
Oh, I see. I thought that 22 was connected to something else.
Well, it's a little bit confusing. I don't often see one like this. Usually when I'm looking at these problems, that would be a regular hexagon as the base. But in this case, it's a half a hexagon. But it's still going to work. In other words, the area of half a hexagon is the area of this trapezoid. What's the general formula for the area of a trapezoid?
Base 1 plus base 2 times height.
It's the average base times height. And you get the average base by adding the two bases and dividing by 2. It's like that. In fact, I like to memorize the area of a trapezoid as the average base times the height. It's easier that way. And you get the average base by adding the two bases and dividing by 2.
So
what do we get here for
18.5?
Let's see, we get 37 divided by 2 is 18.5. Multiply that by 8.
That's 148.
So that's the average of that base. Now, so that's the number that goes there. Multiply it by the height of 36 meters and divide by 3. What do you get? Should be about 1,600, something in that area.
Isn't that the area, though?
That's the volume. What we just calculated was the area of the base only. But if we look at our formula, we need the area of the base times the vertical height of the pyramid divided by 3.
Oh yeah, I thought I meant like because it says base times height, and I meant if that area was the base.
It is, but we're looking for volume. So it's 148 times the height, which is 36, divided by 3 because it's a pyramid, not a cylinder. In other words, it's not a prism. It goes to a point. So you only have 1/3 of the volume that we would have if this thing was a prism with this base at one end.
So is it 1776?
That's it.
And then is all volume is cubed, right?
It's cubic meters. Yes. Area is always square, whatever the units are. Volume is always cube of whatever the units are. Okay. Did you do 5 already?
Kind of.
Let's see, is that an entire sphere? I don't see, your picture didn't quite capture all of 5.
Yeah, it's one of the other photos.
Are we looking at a sphere? A full sphere?
One of the other photos has it on there.
Okay, what are the dimensions of the sphere? The radius is the only thing that matters.
Volume.
What's the radius of the sphere?
It doesn't give it. You're trying to find the diameter.
What does it give? Because in my picture, it doesn't give. I don't see anything. You can see. So what information does it give?
One of the other photos I sent has that one on it.
Okay, but you can tell it to me. What information do they give you here?
The volume is 972 pi centimeters cubed.
972 pi centimeters cubed. Okay. Well, if we take the general volume, what's the general formula?
4/3 pi r cubed.
Okay. And they've given us the volume, so we're going to substitute 972 for that. Now we have to solve for r. So solve this equation for r. No, they gave us 972 pi, right?
Yeah.
Okay. So
I canceled out the pi on both sides.
I'm sorry, what was the first step? Divide by pi? Yep.
Yeah.
Okay. Now what?
I got 972 equals 4/3 r cubed.
Correct.
And so I times 972 to 4/3.
You actually want to multiply it by 3/4. You see why? In other words, we want to get rid of this 4/3. We do that by multiplying both sides by 3/4. Or you can look at it as multiplying both sides by 3 and then dividing both sides by 4. Same thing. But you're going to multiply by 3/4.
So it just switches?
Well, we're trying to turn this into a 1, right?
Yeah.
So I can divide by 4/3, but that's the same as multiplying by 3/4.
So 729 equals r cubed.
And then take the cube root of that number. Sounds like a perfect cube number. I'm guessing.
How do you do that again?
What's the cube root of 729?
Yeah, how do you take the cube root again?
Take 729 and raise it to the 1/3 power. It's a little tricky if you do it that way because you have to put the 1/3 in parentheses. You could also take 729 and raise it to the 0.333 power, which is a little easier to do on your calculator.
That's a 9.
Okay, so that's 9. Okay, so the radius is 9. All right. Number 6, what information do they give you and what information do they want? Looks like we have a diameter of the cone being 16 inches. That's the only thing I can see.
Yeah, we have h is the height, and it says the volume is 448 pi.
448 pi. Okay, let's start with the general formula for volume of a cone. What is it?
That's base times height divided by 3.
Okay. That means the area of the base times the height. So what's the area of that base? It's a circle.
16 pi r squared.
What's the radius of that base?
8.
So it's 8 squared pi.
Okay.
Right? In other words, area is pi r squared, and r is 8. So the area is going to be 64 pi. Okay? So the volume, which is 448 pi, equals the area of the base, which is 64 pi, times h divided by 3, and I assume they want to know what h is.
Yeah.
Okay. Now to solve this for h,
Just writing it down.
okay.
And then you take out the pi, or can you do that in this
No,
situation?
you can divide both sides by pi, and then you can multiply both sides by 3 and divide both sides by 64.
So divide both sides by 3?
No? The 3 is
Or
dividing right now. You always have to do the opposite of whatever those numbers are currently doing. The 64 is multiplying, so we're going to need to divide by 64. But the 3 is dividing, so we're going to need to multiply by 3.
And then we divide by 192?
Now divide by 64. In other words, here's what we're looking at. 448 equals 64h divided by 3. That's where we are now. First step, multiply both sides by 3. Second step, divide both sides by 64.
Wouldn't that multiplying both sides by 3 turn the 64 into 192?
No, it's not going to do anything to the 64. If I multiply both sides by 3, here's what I'm going to do. All I'm doing is canceling that 3. Turns the left side into 1300 something. I think that number. So now we have 1344 equals 64 times h. Now divide that number by 64 and you'll have what h is.
Yeah, h is 21.
21?
Yep.
Okay. All right, let's look at your next page here. Photo 2. Ah, that must have been what you were saying. You were trying to describe to me that it's on the next page, and the audio kept going bad every time you did that. I could never hear exactly what you were saying. All right, let's see. Determine the density of an object that weighs 2,500 grams. The object is put in a cylinder container that has a radius of 8 centimeters and a height of 12 and causes the liquid to rise 3.5 centimeters. All right. Hold on a moment. All right. Let's see. Where do I want to put this? I want to put this up here. This. Okay, the object is put in a cylindrical container. And the dimensions of the cylindrical container is a radius of 8 and a height of 12.
Mm-hmm.
So first of all, let's figure out the volume of that cylindrical container all by itself. What's the volume of a prism? This is a prism.
Base times height, so 8 times 12.
Well, what's the base? It's not 8 times 12. It's the area of the base. The base is a circle.
Okay, so 8 times
Hold on.
8
Hold on.
times pi.
A equals pi r squared.
Yep.
So let's solve for A.
That would be 8 pi squared.
Be 64 pi. Right?
Yeah.
Okay, that's step 1, solving for that area right there. Now we're going to multiply that area by the height to get the volume of this cylinder. So 64 pi times 12 gives you volume.
That's 768 pi.
768?
Yep.
Okay. So that's the volume of that container that this object is placed in. Now, when it says it causes the liquid to rise 3.5 centimeters, that's going to give us the volume of the object. Okay, we got to do a couple of things here. In order to determine the density of the object, we need to know its volume, because they're telling us what it weighs. If we know its volume, its density is some number of grams per cubic centimeter. With me? Okay, if I take any object whatsoever, regardless of its shape, and I put it into this container full of water, or it doesn't even say it's full of water, it's got some liquid in it, and it causes the liquid to rise 3.5 centimeters, that tells you the volume of that object. I could have a cube, I could have a sphere, I could have an odd-shaped knife. And if it causes this cylinder to rise by 3.5 centimeters, that's telling us the volume of that object. Well, if I assume that 3.5 centimeters is right there, then what would the volume of that cylinder be if it was only 3.5 centimeters high instead of 12 centimeters high?
That would be 64 times 3.4.
Times 3.5. Let's get a number on that. 60, it's 64 pi times 3.5. What's around 200 pi?
Yeah, that's 224 pi.
Okay, so 224 pi is the amount of volume that that object displaces. Well, that's in cubic centimeters, and the object weighs 2,500 grams. So if we want density, density is a measurement of volume divided by weight. So we're going to take our 224 pi centimeters cubed. Whoops. Density, density is weight divided by volume. Density is weight over volume. Nice of them to give you that. I mean, this is a physics problem. This isn't a geometry problem. But density is weight divided by volume. So it's going to be 2,500 divided by 224 pi is going to be your density.
And you wouldn't keep it in terms of pi?
Well, I don't know. The fact that pi is in the denominator makes it a little, I don't know what to answer that. This is such a strange question on a geometry test because it's a physics question. It's not a geometry. It's a geometry question in the sense of how do you figure out the volume of the cylinder or the volume that was displaced, but then it's a physics problem. And whether they want the physics answer in terms of pi or in terms of a decimal, I don't know. You could leave it with pi in the bottom. It's going to be about 11 or 10 over pi would be its density. And the density would be in grams per cubic centimeter. So those are the units on density, is grams per cubic centimeter.
I got 3.55.
Okay, and that sounds right, because 10 divided by pi is about that number. So 3.55 grams per cubic centimeter. All right, let's go to another page here. Find the volume of the following figures. What's the volume of this cube? What's the formula for volume of a cube?
That's not on there, is it?
Well, look at it. It's a prism, right?
Yeah, so base times height?
Well, we're going to take it's not base times height, it's the area of the base times the height. Well, what's the area of that base you see there?
13 times 13.
And what's the height of the cube?
13.
So the volume of a cube is the one dimension cubed. It's 13 times 13 times 13.
So 13 to the third power?
Cubic meters.
Okay. And for that one.
All right, number 3. Hold on a second. I gotta look these up because these apophthegms and all that, I don't do them often enough to memorize them. Hold on. Let's see. This is under polygons. So we're talking the area of regular polygons. Okay, hold on. All right. Area of a regular, in other words, number 3. That's also a prism. It's important it's important that you be able to recognize prisms. Because as long as you know it's a prism, then it's the area of the base times its vertical height. Always. If it's a prism. Regardless of whether it's sitting right or not. You know what I'm saying? In other words, it's not always the base that's flat on the paper. Sometimes it's a different base. But it's clear that the base that you don't see underneath is the same shape as this base right here. Well, if you have 2 equal opposite bases and it's uniform in between, then it's the area of the base times its vertical height. So what's the area of the base of a regular pentagon? There's a formula for the area of any regular polygon. And it's 1/2 times the apothem times the number of sides times the side length, which also is 1/2 times the apothem times the perimeter. Notice that the number of sides times the side length is the perimeter. But I'm not sure which is easier to memorize. Let's work with this one, because we usually can get all 3 of these numbers. So what's the apothem in this case?
6.9.
Okay, so it's 1/2, 6.9. How many sides do we have?
5.
And what's the length of each side?
10.
So that's the area of the base. Let's get a number on that. Multiply it by the height of 20, and that's your volume.
And that's divided by 1/2, or divided by 2, and then you times that by 20.
Correct.
3,450.
Sounds right. 3,450. Okay. And again, that's cubic centimeters. Number 4 I don't have on this page. Is that on another page or not?
Yeah, it is.
Okay, let me open up another. Yeah, there it is.
It might be a bit blurry, but I can read them out.
No, I can read them. What is this shape? What's it called?
Pyramid?
Yeah. So what's the volume going to be on this pyramid?
Base times height divided by 3.
Again, it's the area of the base. Okay? In other words, typically when you say base, it's a one-dimensional thing. If you're finding the area of a rectangle, you say base times height. Well, base is one dimension. In these problems, it's not the base, it's the area of the base. So the area of the base is going to be dimension squared. It's going to be in square inches here. Well, what's the area of, what figure makes up the base here? What kind of figure is that?
Triangle?
Okay, what's the area of a triangle?
Base times height?
No.
1/2 base times height.
1/2 base times height. Okay. So, hold on one moment.
That's 88 times 21.
Let's see, we got 1/2, the base times 21 is the vertical height of that triangle. So what's 1/2 88 times 21?
$924.
Okay, and then we're going to take that, and remember that's in square inches, because all that is the area of that triangle. We're going to take that, multiply it by this vertical height of 66, is that 66?
Yeah.
And then divide it by 3.
And that's 924 squared, you said?
It's just 924. It is in square centimeters. Watch what happens here. The area of that base is in square inches, actually. Inches squared. And then I'm going to multiply it by the height, which is 66 inches. So I got inches squared times inches. That's cubic inches. That's what we want volume to be in, is cubic inches.
Okay.
Okay? So it's 924 times 66 divided by 3. What's that?
That's 20,328
cubic inches. The volume will always come out right if you put, in other words, we got the area by 88 inches times 21 inches. Inches times inches gave us square inches. So this is in square inches. We multiply it by inches, we get cubic inches.
Okay.
What shape is number 5? Hold on one moment.
This is like a triangle. I'd rather go to 8.
I'm gonna let my dog out. Excuse me 1 minute. Okay, I'm sorry, what?
I'd rather go to 8 if we could.
Okay. That must be on the previous page that we had it up. No? Alright, let me open up the 4th document. Maybe the 5th document. Okay. What shape is that? What's it called?
Hexagon.
It's a prism. Remember the idea of prism, because if you can remember what the volume of a prism is, it'll cover all kinds of shapes. The volume of a prism is the area of one base times its length or height, whichever it may be. But the base is this thing here. And the equal and opposite base on the other side is that thing there. it makes it a prism. In other words, no matter where I slice this object, I'm looking at a cross-section that looks exactly like that. So we need to figure out the area of the base. In other words, we know the volume is going to be the area of the base times its height. It's misleading a little bit because it's not really height, it's length in this case. It really means, the h really means the distance between the two equal and opposite faces. So remember, the area of the base was 1/2 the apothem times the number of sides times the side length. Well, they're going to make us figure out all kinds of things here. They've only given us the apothem. But they've given us the perimeter. So does that tell us, remember that formula where I said 1/2 the apothem times the perimeter, because the number of sides times the side length is the perimeter. So let's use this formula. 1/2 the apothem, which is what?
22.5.
And the perimeter that they give us is 156. So what is the area of the base? 1700 something?
1755.
And that is in square centimeters. Okay? So now to get the volume, just plug that in for that, multiply it by the height, which is what?
78.
Right. In other words, h doesn't always mean height. It's hard to think of that as height. It's more like a length. But it's the distance between the two equal bases. So 1755 times 78.
All right.
Okay.
So this one,
This one doesn't have a name for that object.
yeah, because that's two objects.
It's not a prism. Yeah, exactly. It's two objects put together. The bottom object is what?
A cylinder.
The top object is?
A cone.
Okay, let's do the cylinder first. What is the... Wow. Okay, they're going to make us do a lot of work on this one. They don't give us the radius of this thing. And in order to figure out the volume of the cylinder, or for that matter, the volume of the cone, we're going to need the radius of that circle. Well, what do they give us? They give us the height of the cylinder, which is 44. They give us the height of the total pencil, which is 54.
64.
64, which makes the height of this part right here 20. So, in other words, we're looking at a triangle. If I were to split this thing to try to figure out, this height is 20 right there, they're giving us this side is 25. So whatever this is right there is the radius of that circle. You see that?
Yeah.
Okay, what is that?
25 squared minus 24, 20 squared.
Okay, it's also recognized that as a 3, 4, 5 triangle. That's got to be 15. In other words, it's a multiple of a 3, 4, 5 triangle. And it'll save you a lot of arithmetic and time to recognize those. In other words, I didn't have to put that through the Pythagorean theorem. I saw that it was a 3, 4, 5 triangle multiplied by 5. So this side has to be 15. Now we have the radius of that. So the volume of the cylinder is what?
Base times height.
And the base is what?
R squared pi.
And R is what?
R is 15.
Right. So it's 225 pi. That's the area of the base in square millimeters.
And the height is 20.
No, the height is what? Of the cylinder.
Oh, the cylinder?
Huh? You gotta do this as two separate figures. We got to figure out the height of the cylinder, and then we got to figure out the height of the volume of the cone also.
Yeah, I was doing the height of the cone.
Okay, so let's do the height of the cylinder first.
That's 44.
Okay, so 44 times this number.
That's 9,900.
Pi, right?
Yeah.
Okay. And then the height or the volume of the cone. And one way that I've found very useful for memorizing cones and pyramids is it's the equivalent, it's 1/3 of what the volume would be if it was a full cylinder all the way up. You know what I'm saying?
Kind of.
Well, if I took let's take a cylinder like this. For me to turn that into a cone, I got to shave away 2/3 of it. That's the way I think of it. So that the volume of the cylinder is only, the volume of that cone is only going to be 1/3 of what the volume of the full cylinder would be. So that's how you memorize a cone, is it's base times height divided by 3. It's 1/3. Okay.
So you could just take 9,900 and divide it by 3?
No, we got a different height on this cone. What's the height of that cone?
20.
Okay. So it's that number, that's the area of the base of the cone, times its height, which is 20, divided by 3 because it's a cone, not a cylinder.
Wait, so what are we timesing by 20?
The volume of the cone is its base. Okay, I got this wrong. The base of that cone is 225 pi. Right?
Yeah.
Times its height, 20, divided by 3 because it's a cone, not a cylinder. So what's that number?
All right.
And then we have to add that to 9,900 pi to get the volume of the entire pencil.
And that's 1,500 pi.
Okay, so add 1,500 pi to 9,900 pi, and I think you get 11,400 pi.
Yep.
And that's the volume of both objects joined together.
Yep.
Now, you have to do surface areas also?
I'm better with surface areas.
Well, they're a little trickier with surface areas because notice that one surface is missing. The base of the cone is missing and the top of the cylinder is missing from surface area. So when you do surface area on these things, you have to take that into account. In other words, it's not the surface area of the cylinder plus the surface area of the cone. It's the surface area of the cylinder minus the area of the top of the cylinder because it's not showing. In other words, if I had to paint this object, I wouldn't have to paint that area.
Yeah.
And you also don't have the base of the cone, so it's only the lateral surface area of the cone. It's the lateral surface area of the cone plus the lateral surface area of the cylinder plus the area of the base of the cylinder is how you would do surface area on an object like this. It's actually harder to do surface area because you have to chop it up and subtract off some surfaces. Whereas when you're doing volumes, the volume is the same as the volume if I had two separate pieces here. If I just had a cone and a cylinder, the volume of this object is the volume of the cone and the volume of the cylinder. But the surface area of this object is not the surface area of the cone plus the surface area of the cylinder. Because the surface area of the top of the cylinder is covered up by the bottom of the cone.
All right.
All right, we're going to have to end it there because I have a 6:30. But, let me get your email. Let's see, I got your mom's email. Is it okay to send? Once I get this file processed, which won't be until tomorrow morning, I will send you a link as to how to retrieve the recording of it.
Okay.
And it may or may not be useful to you. If you forget how to do some of these, you'll be able to go back and review how we did it. So it might be useful to you. And I'll just send that link to your mom's email, if that works.
Mm-hmm.
Okay, cool. So that's my online session. What did you think of it?
I liked it. I think I like the in-person sessions a bit better.
Okay,
though.
well, that's fine. I have no problem. You only live 5 minutes from here. But unfortunately, today my car wouldn't start, and I got to figure out how to get it going again.
Yeah.
I'll do that in the morning. I got nothing but tutoring sessions tonight. They're all online, thank goodness. Yours was the only one that was in person. So anyway, I will plan on seeing you next Tuesday at the normal time.
Yep.
Okay. Talk to you then.
All right. Thank you very much. Have a good night.
You too, Grace.